What is this, Lady Ada?
Hey, everybody, and welcome to another episode of Show and Tell. It's 7:30 p.m. Eastern, and it's snowy outside, so get your Swiss Miss and your soldering iron. Come on by. We're going to check in with people from around the making, hacking, electronic engineering, and more community to see what they're up to. First up is Kevin from Digi-Key.
Hey, guys. How you doing?
Hey, Kevin.
So you guys have snow.
Tomorrow we will.
Yeah, New York has snow. I mean, like, we're not.
In fact, it's twice as
Texas.
It's twice as snowy. I think our average is like 17 inches, and now it's 33. So we're already ahead of schedule.
Yeah.
We're way below schedule on snow.
Yeah.
But today it went above zero, so it was a good.
There you
day.
go.
Huh. Okay, good.
It was a good day.
So t-shirt weather, cool.
Yeah, exactly. So what I've been working on is next week is National Engineers Week. And we have our annual Girls' Night Out, which it's going virtual this year, of course. And some of our team members put together this little project, put it around my neck just so you can see the lights. It's not actually a necklace.
Yes, it is.
It is now. Using the microbit V2 and some of the new features on it, you touch the capacitive touch, and then you can adjust the colors. LEDs are so hard.
No, we can see it. Oh, there you go.
There you go. So you're increasing the red. Now I'm going to increase the green. And then increase the blue. So you can change the colors by changing the RGB on here. And then you shake it, and it's going to change the function on here.
Nice
So
use.
Like I said, this is for Girls' Night Out. So we have a group of young females here in the local area, and they're going to do this project. Right now it's on a VU meter. As I talk, it's...
Yeah. The microphone built in is awesome.
But yeah, any 12 through 18-year-olds are going to come together, put together a project, and have some fun. So my next goal is to get this moved over to the Clue.
Okay.
And then add a display on here. So I think it'll be a really cool project for adding to the Clue. Because obviously the Clue is the exact same size.
That's right. And we definitely have VU code for the PDM microphone on the Clue.
Yeah, you have a code for all of this stuff.
Yeah.
So
all right, sweet.
Very cool.
All right. Also try Circuit Playground Express. That's another board you could try.
Yeah, we have the Circuit Playground. I happen to have one right here. We did a project on the Circuit Playground Express last year. So we're trying something a little different this year. The nice thing about the Express is everything's all built in. All the LEDs, neopixels, lights, sensors. It's great.
All right, sweet. Thank you, Kevin. Nice update. Stay
You're
warm.
welcome.
All right. At least if the power goes out, you have your neopixel necklace to light your way. Next up is Melissa.
Hello.
What's up, Melissa?
Hi, I have this board here, and it has an old chip on here. It's called the VCP200. It's from like the late 80s. And I had gotten it working a long time ago as a kid, and I soldered it to a board, and then it didn't work for some reason. Anyway, I dug it out when I was going through my parts, and I decided to wire it up to this board here. And so I have it working. So if I say stuff like lights, let's see, it's not working. Reset. Well, just a second.
You want to repower it? Live voice demos are the worst.
Oh, yeah. This thing has been a little bit finicky. Right now I have it running at 3 volt. Oh, I just reset it. It works fine when I power it through my benchtop power supply, but I was trying out some various power supplies last night, and I thought it was working through the Feather, but...
We believe you. All right, so
okay.
It basically recognizes like just 5 different words.
There's actually like 8 words that it'll recognize. 3 of them weren't like documented in the original Radio Shack documentation. There was like an article in a magazine that had like the additional words on there.
Yeah.
I think it was like lights, reset, and slow or something like that.
All right. Well, this is the pre-Alexa Alexa. All right, that's cool. I love hacking on old electronics because, like, like people did a lot with very little. It's very impressive.
Mm-hmm.
All right. Well, thanks for coming by, Melissa. And then if you get it working, let us know. We'll bring you back and you can turn on.
Okay. I'll hook it up to my benchtop and then.
Yeah.
Okay.
All right, well, we're gonna keep going. But yeah, just raise your hand. Wait.
Okay.
All right, next up is JP.
Hey guys, so this is a project on a MagTag I wanted to show, and the setup for this is that Lady 8 is probably wondering what time in NCAA men's basketball today are the Arizona State Sun Devils going to play their game?
Oh, no.
USC here in LA against the Trojans. Well,
Yeah. Boom.
I'll tell you what, it's going to be at 5 p.m.
Yes, and it's game 1 out of 5.
It is. Well, so there's 5 games happening today. It's going to be airing on ESPN2. I do want to warn people that I have a mistake in my date time code right now, and so it says this game is happening tomorrow instead of today. So I'm going to cover that up so no one gets mad on the internet.
Sweet.
But what we can do is hit a button here on the MagTag, and it's going to go ahead and grab the next of the 5 scheduled games in NCAA men's basketball, so we can see that
Loyola. Okay.
times, and if the game has been postponed, it'll say that down at the bottom. If the game is already final, it'll post the score on there. It tells us again where it's airing. We can even hit this will take a moment, but I'm going to hit a button here while I talk. That's going to go and grab a completely different sport. So it's going to go grab women's NCAA basketball schedule, and we can grab a ton of these. There's a really good you know what, I'm not in my same Wi-Fi as I was when I started this, so now it's broken. We can put that away now.
I'll try resetting it. Okay, all right. Well, okay, live demo. Okay,
So
but
the ESPN API 2 has a JSON file, different URL per sport, but it's really consistent. It's really great set of data that you can grab all this from. So I'd hacked some stuff together using some MagTag code. It worked, but it was every page it went to, it kind of pulled down the full JSON file. So Melissa helped me by rewriting it so that it grabs it once and stores the data, and then I can page through it quickly, so we can hit the next game, previous game, and then we can also do a full refresh, which you'd want to do when you have had it sitting around for a while. But it's essentially the thing that people, I've talked to people who watch sports a lot. I don't, but I've talked to people and they say, yeah, the main thing is where is it playing? Like, I kind of know what day, I might even know what time, but which ESPN, because there's like 90 of them, is playing it. So this thing helps you, and it's not just ESPN, it'll tell you
this
where.
is actually also one of the first projects we want to do in the MagTag, but we had to improve the JSON handling and the parsing. Like, there's a lot of stuff that had to happen. The ESPN data chunk is massive, and it's really complicated, but I'm glad that this is we're finally getting to this project.
Yeah, and in fact, discovering this error in my date time code, which is semi-janky, and I just kind of got it working barely, led us to a discussion of talking to Brent and Jepler about putting a proper datetime library that we have in here that'll use the ISO format time that ESPN uses in their API. Yeah. So it'll be sort of this layering on of these chunks of code that we really spruced up to do different projects, and it all comes together in Adafruit's favorite, sports ball.
CiruitPython sports ball. All right. Thanks, JP. Look forward to that guide. And then you just published a guide on using motors and robotics in CiruitPython with the new Raspberry Pi Pico.
Right. That's right. Yeah. And I had shown this thing, which is a demo board with a whole bunch of different motor projects all built onto one. This guide will tell you how to do each one of those discretely, so you don't have to worry about, I don't care about solenoids, I just want steppers. It'll take you through those with a nice fritzing diagram per, and the code just for that, so you can get started really quickly with the Pico. But you can do them all. There's a lot of GPIO on Pico, so you can do them all as a bazillion PWM channels you can work with. So if you want, the last page of that guide will let you set up the science fair style board there and put them all together.
All right, thank you, JP.
All right.
Always bringing cool tronics and the sports ball. Next up, Erin, our favorite fairy.
Hello. So I have been wanting this project for years and working on it for, it feels like, months and months, but they're finally finished. So I am holding here a pair of animatronic fairy wings. I have hooked up a little steampunk bracelet here with a potentiometer knob, and when I turn it on, if all goes well, the wings will start flapping. And the knob actually can adjust the speed of how fast they go, and there's a bunch of just randomness and fun. I tried to make them as organic as possible with the code, so that they flap sort of a random number of times and then pause, and it's a lot of fun. I
love the jewels, and it's iridescent. This is like everything that you do, and you kind of decorated over the mechatronic part. It looks great.
Yeah, and I went kind of steampunk. I've got little keys on here that we can turn and pretend to wind them up and that sort of thing. So it's really been a fun project, and I've been working on the tutorial on how to make these super light cellophane fairy wings with a Cricut Maker. And so there's no water jet cutting or anything needed for these fancy frames, but they're just giant and huge and wonderful. And I think I'm going to have to really fly.
The steampunk part's really smart because that explains why it like makes the servo noise. You're like, no, it's mechatronic. Like
exactly.
You know what I mean? Like you lean into like it's a robotic project, but it's like a steampunk robot. So cool.
Yeah.
All right, nice work. Thanks, Erin. And that guide's coming out soon.
Yeah, coming out very soon. So
all right. So sneak peek.
All right, next up, Noe Pedro.
Hey guys. So this week we got a video and a little 3D printed case for Carter's awesome guide that he came out a couple weeks ago. And then I noticed you guys are adding this to the offices. So it's a CO2 sensor using the Pi Portal Matrix. And inside, oh, do I have the screen set up?
I can't add it.
Oh. We got this. Yeah, it's just this guy. So it's a bracket and 3D printed case for the, what is it, SCD30.
So the screen didn't actually add, by the way.
Something weird.
Nah,
yeah, do you want me to try to add it? Yeah, it.
Oh, there you go.
Yeah, okay, so here it is. It's just a case for the SCD30 sensor in here. So it's measuring the CO2 levels, and I'm kind of embarrassed to show the numbers here since we have no AC running. We're in a closed room, but we're all good.
I'm holding my breath.
So, of course, Stemma QT, and I made these because I saw the guide that Carter came out with, and I noticed you guys are adding these into the office. So it's this guy. It's all press fit, so it just goes into the case like that. There's no screws that are required, and it's just hooked up with the Stemma QT cable on there. On the back, you can just see it's just a little bracket that hooks up to the heat set screws that are on the Matrix displays that came with the Ada box. And I made a different size too for like the bigger ones that were used in the protest sign project. So it's just a little simple case. And then Carter had a really good idea of having this nice little faceplate that has the CO2 logo on there. So it's a nice little way to monitor what your CO2 levels are. So it's supposed to be used for like if in a room, if it gets like too crowded, you can see the levels rising. You can open up a window, get some air circulation, or disperse. So nice little case for that. Cool little easy project to go along with the times, unfortunately.
Open up that window.
And Melissa's project is working, so we're going to go to Melissa real quick, and then we're going to try to get to everyone real quick. So as long as everyone speeds it up in turbo mode, we can still get to everyone.
Okay, Melissa, you ready to do your demo?
Yes, I am. Okay, so I just hooked it up to my benchtop supply here, so I can say stuff like stop, turn left, reset, lights. And so you can see like different LEDs will light up.
Yay! You got it working.
Yeah.
Radio Shack 1985 technology.
Thanks.
All right, sweet.
All right, we're going to keep moving. Now, Dan
and Dan's screen.
Okay. So I want to say what I'm working on is a second serial channel that goes over USB to your CiruitPython board. So here's my whiteboard.
Okay.
So you see that I got a computer.
Yeah.
And it used to be that we just talk to the CiruitPython board over the REPL, over the USB cable. But I'm adding a second channel so that you can talk where it says new. This is really hard.
No. Yeah. This is like Feynman level. You're doing great.
Yeah, and so now you're going to be able to talk to your CiruitPython board over 2 channels rather than 1, so that you could exchange data with the board if you want to communicate with the board, and the REPL is not going to get in the way. Right now, you've been able to read and write through the REPL, but if you want to print things or something, you always get messed up. If you want to send a Control-C, it screws things up. But here we can have a new channel that sends bytes back and forth.
Okay.
To your Python board from your host.
Demo it.
All right. If you look here, I plugged in the CircuitPython board. I just have a Metro M4 here, and now it's showing two devices, ACM0 and ACM1. Or if this were Windows, it would be like COM15 and COM16 or something. And so on the circuit, there's the REPL, and there's this new module USB CDC, and it has this list in it called serials, and it's serials of 0 and serials of 1. Serials of 0 is the REPL, serials of 1 is this new channel. So I made a variable here, and on the left side here, I started up Python, and I'm running Pi serial, but I could be running a terminal program or something. It doesn't.
Get to the demo.
Yeah. All
Write
right.
the bytes.
S1.write. Oops. So let's write some bytes.
Yeah. Okay.
All right. And let's over here, we're going to say ACM1.read.
Yeah.
3 bytes. There they are.
Whoa.
ABC goes from one side to the other over the USB, and it doesn't get messed up in the REPL. So you can write a program that uses these USB serials to send data back and forth. And that's it.
It's epic. It's amazing. It's great. People are going to love this. I think, I know that AT makers have also been asking for this, as well as many, many other people. This is going to really unlock the ability for CiruitPython boards to interact with computers, which is powerful. So good work, Dan. Very exciting. Coming soon to basically every CiruitPython board except the SAMD21, which doesn't have enough endpoints. But Pico can do it, SAMD51, STM32F405, maybe even the ESP32S2. So everyone stay tuned. This is a sneak peek.
Okay.
Thank you, Dan.
All
right, next up, Scott.
I think Dan needs to make a commercial. He needs like a 30-second spot about the second serial CDC. Like
He will. Well,
he's got all of the elements.
Well, he's like number 2 on TikTok.
We've lined up David Blaine.
All right, here's what I got. I know you got lots of folks. So it's a RP2040 Feather, and which way am I going? A Max I2S amplifier, and then I've got just a speaker hanging off here. So I'm just going to hopefully Control D. It's a little quiet.
I heard like oh yeah, there's like a little chime.
Yeah, it's the Jet Player Splash sound that I've been testing with. But basically, we have I2S audio playback working in CircuitPython. I'm hoping to actually do PDM microphone recording as well while I'm at it. So hopefully we'll have a PR for all of that by the end of the week, and PIO improvements as well, which will be good.
Yay, so much stuff happening. Speaking of PIO, let's go to Jepler, who I heard has a cool PIO demo.
I have LEDs.
Okay.
So, I mean, we've done LEDs before, right? What's different about this one is we're using the PIO peripheral in the Raspberry Pi 2040 Pico and a shift register, which you can't see down here on my nest of wires, to go to 8 independent neopixel strips. So they're each being driven at the same time, but instead of being like a zigzag or an S configuration, they're all coming directly off of one spot, which is faster to update and gives you some more options for how to lay out your LEDs. And it's also been a good experience learning about the PIO coprocessor of this chip. So
yeah,
that's what I got.
This is a project that I actually, Phil B and I tried to do a few years ago on the SAMD21. We tried to, it's a shift register, so it's actually only using 3 pins.
Right, it uses 3 pins.
You shift out data so fast that the data appears on the output of the shift register at 800 kilohertz, writing neopixels. We thought this would be a cool way of like, because like how do you write 8 bits at a time? Well, you could use a shift register because you clock them all at once. Because there was no DMA on the SAMD21, but we couldn't get it working on the SAMD21 because of that latch pin. You have to latch the pin really fast right after you write the 8 bits, and like, so you can't use SPI, and we tried to do a timer and it would get out of sync. But with PIO, it's like, wow, perfect.
Yeah, it worked actually on the first try that I actually hooked up LEDs. So that's always a pleasant surprise.
Impressive.
There was a lot of times that I didn't have the LEDs hooked up and it didn't work. And
but when you actually
went
wanted
to analyzer.
Yeah, when you went to try. Okay. Well, you get credit for that. All right. Well, nice work, Jeff. Well, that's also coming soon.
All right. Yeah. So we've got code to add to the core. We've got guides to write and all that stuff. So it'll be coming. You can use it.
All right. Thanks,
Thank you,
Jepler. A little programming note. Scott's deep dive is tomorrow. Just a reminder. It's normally Friday, but it is tomorrow, Thursday. That is breaking news.
Breaking news.
All right. Next up, let's go to Seth, and then we'll go to Alvaro, and then we'll go to Liz. If we can keep it to a couple minutes each, we can still do this.
All right, Seth. Hey, Seth.
Alrighty. So it's been a while since I've been on, but I've been very, very busy. I decided to take some of my designs that I've showed on here before, like the little power pack for the Cutie Pie and a little SAMD21 board I made, and I made them better. So I made it smaller. I think it's 2 pins more than the Cutie Pie.
Yeah.
And then I've got a little high-speed analog to digital converter that actually does I²C. And then the new Cutie Pie Power Pack that I've been working on is even smaller, and it comes in I added some reverse voltage protection too, but it's almost the same size as the Cutie Pie now, and it's been a lot of fun. And then I've actually been writing a few driver codes that have been submitted to the community library too for some of the boards that I've been making. Like I've got the AT42QT. One of Microchip's capacitive touch boards. So there wasn't a CircuitPython library, so I added that on there, and still adding more functionality to it because there's so much that this little chip can do that I didn't realize when I initially started writing the driver code for it. So.
Great work, and congratulations! There's going to be a Pico, RP2040 Cutie Pie, so that your stuff will work with that too. So. Hopefully more boards in the future. And there might be an ESP32S2 one as well that's in the works.
Yeah, I've actually been working on a small form factor ESP32S2. So this one only does 6 pins or 12 pins on it, but I didn't quite get it to work the first time around. So Rev-B hopefully is much better.
Okay.
So,
all right.
Good luck.
Seth.
Thank you, Seth.
Thanks, guys.
All right, next up, Alvaro.
Hey, everybody.
Hi.
So I'm going to show today something that I'm a bit nervous, not only because I'm in the show, but because this is really expensive, especially for me.
Oh.
This is actually the one of the first 64-bit RISC-V chips. So you can see the Sci-Fi.
Oh yeah, those are expensive.
Like $1,000, and like we're in Costa Rica, so $1,000 is a lot of money.
Yeah.
So that's why I'm using gloves, and this is the board, the real board that I'm actually using for developing Slackware. So I'm just going to put it down because I don't want to damage it. And the thing that I wanted to say is that there's a lot of other RISC-V things coming up. So I wanted to show really quick the first product. This is a Pine 64 soldering item. It's a clone of the TS100. But yeah, it actually has a RISC-V chip in it, and it doesn't say RISC-V anywhere. So I actually consider this like the first RISC-V product. Not a development part. Yeah. And also really quick from the people from Pine, I also got this. This is the BL2 602 chip. Yeah. So they're actually trying to make it like a chip ESP 8266, like only a Wi-Fi processor. So yeah, this is what I have for today. So
that's awesome. Thank you for coming by. And also, that's a sweet guitar and a really sweet old PC classic on your wall.
Yeah, actually, the old PC. Some of the things that I'm doing for RISC-V is because actually I want to make a new motherboard.
Totally, absolutely, with an e-ink screen like the original was supposed to be. Like that'd be so cool.
And thanks for
coming out.
Thanks for showing the productized RISC-V, because that's when you know things are really taking off, when it's invisible and embedded inside of everything. So good first example.
Sure.
All right.
Yeah, the Pico 5 are coming out, and also the Alibaba chips are coming out. And the people from Pine actually said that they're going to build a small computer with these things. So it's going to go from $1,000 to $1,500.
If you ever see a RISC-V that has like USB, so we could do CircuitPython stuff, let us know.
Yeah. No, I have samples of this stuff, but
okay.
Yeah. All right. Thank you so much, Alvaro.
Right on. All right, Liz, play us out.
Hello. I actually do have a Midi thing cooking. So
That's right.
So I got a Pico display screen that is going to be showing all of the different MIDI buttons. And then this is the new LED driver. I'm blanking on the name, but it's going through Stemma.
Yeah.
And so basically when I press this button here.
Press it.
Oh, my cat's jumping down. It's hitting the robot xylophone back of me. And I'm just testing the LED. It's launching it. And then the feature of this is when I select this, then the LED is going to blink to let you know you selected that pin. And then I can change the MIDI note. It will, I can change the MIDI note. There we go. And now it's going to play a different tone. Maybe.
Maybe not.
Yeah.
Robots are so finicky.
I know. I know we're short on time, so I can stop. But maybe try that one. Okay, I'm gonna call it. But it changes the note, and yeah. But yeah, the big thing this week was getting the lights integrated in. So
Yeah, I like that new GPIO expander because you don't have to have a resistor with the LEDs. So I thought like it would make wiring a lot easier. It's like it's a pretty strong drive. You can drive like pretty bright LEDs. But come by next week. I'm sure I see you're working on this project every week. So come by next week.
Yes, and then I've the purple thing back there is the case. So hopefully next week it'll be all assembled and everything.
Oh, nice. All right. Well, that's awesome.
All right. Thanks so much, Liz.
All right. Thanks, Liz.
All right. That's our show for tonight, everybody. Thanks for stopping by. 7:30 p.m. Eastern Standard Time. Especially thank Noe Pedro, who did show and tell last couple weeks. We're here this week. We'll probably be here next week, but we're alternating everyone so our team can host show and tell throughout the months and years. So we're going to keep doing this. We'll see everybody at Ask an Engineer, which starts in about 5 minutes, 8 p.m. Wednesdays. And see you next week right here, show and tell, 7:30 p.m. Show and share your favorite projects or just about anything, including retro stuff or just things that you want to get out there. We'll see you next week.
All right. Thanks, everybody.